Hi, good to see you again. Welcome to Block 4, Operations and Equations with Directed Numbers. Lesson 13. I'll share my screen. In today's lesson, you're going to learn roots of positive numbers. Recall that in your previous lesson, you learned how to work with directed numbers using BIDMAS or order of operations, the way some people would call it. Before we start, I would like you to like the video, subscribe to the channel, share the video with those you think can benefit, and then click on the notification bell so that when new videos are released, you will be notified. By doing so, you help us support our mission to provide a resource or a platform where children, regardless of their economic circumstance, can have access to high quality education provided they have access to the internet. So one charitable work you can do is to provide internet access to children, and there is a free resource for them to use to study maths. Before we start, I would like you to do the retrieval practice questions in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So you were simply asked to work out these calculations. So by now, you should know the relationship between the signs when you work with directed numbers. So you know a negative and a positive will give you a negative. That's why the answer is negative 77. You know that negative multiplied by a negative will give you a positive. You know that a negative multiplied by a negative will give you a negative. That's why we have negative 121. And then a positive multiplied by a negative will give you a negative. That's why you have negative 121. And then two negatives will multiply to give you a positive. That's why we have 121. So this is to help you recall the things you learned in the previous lessons. Let's do our first learning. So if you think about this, what do you notice about what you see here? So here you're asked to fill in the missing numbers in each calculation. Now, if we fill in the missing numbers, we can see that we're squaring the numbers. So we're squaring the numbers, and that gives us these numbers. Well, I'm sure you've noticed that the square of the positive number gives the same result as the square, although you must put the square, the negative number in a bracket, gives the same result as the square of the negative number. So if you were to do this in a calculator, you must use the bracket to ensure that you have the correct result. And we have looked at this in our previous lessons. But let me ask you this. What is the inverse of squaring a number? If the inverse of adding is to subtract and the inverse of multiplying is to divide, and vice versa, what is the inverse of squaring a number? Well, the inverse of squaring a number is to find the square root of a number. So, if we have 4 squared equal to 16, know that negative 4 squared is also equal to 16. So the inverse of squaring 4, if we do the square root of 16, we're going to get 4. Have you noticed that we didn't write negative 4? Yes, we didn't write negative 4 because using the square root symbol, we are only interested in the positive number. We wouldn't say negative 4. But you would see a different case where we have to use negative 4 when we are solving equations, and you would see why. I'm going to explain that. So we only work with a positive number, even though we know that negative squaring a negative number will also give the number that we could square, that we could take a square root of to get the positive number. So this is interesting because what it means is when we have equate something where we have to do negative square root 16, we know that our answer will actually be negative 4. So it's really important for you to note that the square root of the number is only the positive number. We're only interested in that. It's now time for you to pause the video and answer questions 1 to 4. So pause the video and answer questions 1 and 2 in 4 minutes. You could take a longer time, you could take a shorter time. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So here you were asked to calculate the squares. All right? So calculating the square simply means to square these numbers. All right? And you can see here, a particular interest is this one. So here you're squaring the 7, but don't forget that you have a negative influencing your result. And then 0 squared is 0 times 0, which is 0. Here you can see that the bracket influences your result because negative 7 in bracket squared means negative 7 times negative 7, which will give us positive 49 or 49. Here you are asked to write the numbers in the correct place in the square sorting table. So these are square numbers, these are not square numbers, and then these are negative numbers. Okay, that's all you were required to do. Pause the video and answer questions 3 and 4 in 3 minutes. Assuming you've paused the video and you've answered questions 3 and 4, here are the answers. So here you're asked, Mo is finding the square root of 64. Mo said to find the square root of a number, you divide by 2. The answer can be positive or negative. And here is what Mo did. Well, Mo is not correct. Why? Calculating the square root of a number isn't the same as dividing by 2. All right? So calculating the square root of a number involves using the square root symbol. Here is the answer to question 4. You were asked, we know that 6 squared is equal to 36 and negative 6 squared is equal to 36. Now remember, the negative 6 squared must be in a bracket for you to get 36, which is positive. So we also know that if x squared is equal to 36, then x is equal to 6 and x is equal to negative 6. So we're now required to solve the equations. Now I am going to explain why we have x equal to 6 and x is equal to negative 6, whereas when we did the square root of 36, we only chose the positive as the answer. I would explain in the context of solving equations why we must accept the two numbers as the result. So here are the answers, and you can see it there. Okay, so these are using your square root symbol, you will get these results, although it's positive, but you must know that we'll have two results, the positive and the negative, because they satisfy the answer. But let me explain it here, although we'll see it again in the next section of our lesson. Now, we have this equation x squared is equal to 36. If these results are right, it means if we substitute this in here, we should get the same answer. So for the first one, that's straightforward. X is 6, so 6 squared is equal to 36. We know that. For the next one, x is negative 6. So remember, we're squaring x. So we have to hold that in a bracket because we're squaring x, the whole of x. So we know that negative 6 squared is negative 6 times negative 6, which is equal to 36. So when solving equations, we must accept that the result is x equal to 6 and x equal to negative 6. We would see further explanation about this in the next slide. Now, use a calculator to find the square root of 10. So we're now moving into the next part of our lesson. If you do that, you must use a button that looks like this in your calculator. If you do that, you will find something that looks like that. That is not very helpful because we need an actual decimal in on many occasions when we work in maths. So to do that, we use this button, which is called standard to decimal. So when we press that button, it changes the result to a decimal number. So now you have learned how to use your calculator to do square roots of numbers that you do not have an integer after you finish doing the square root. For example, our square numbers. So this number is approximately 3.16 to 3 significant figure. So something you must know is calculators normally only give the positive square root. So we only use the positive square root. But when we solve this equation, what do you notice? Is there a mistake? Of course there is. The mistake is when we solve an equation, remember that I said our aim in our previous lesson, our aim is to make the variable stand on its own where we'll have k equal to something. Now, the thing that is preventing that from happening at the moment is the squaring of k. Now remember, we did say, or we did learn, that the inverse of squaring is to do the square root. So to be able to get rid of the squaring of the k so that we can have just k, we have to do the square root of both sides. And that is why this calculation is wrong. So if we do the square root of both sides, that cancels out, and we now have square root 20. But of course, remember from the last question we looked at in the previous slide, that when you solve equations, you must have k equal to positive and negative 20. Why? We saw that if we have the positive and the negative results and we substitute it back into the equations like this, we will get the same accurate result. So take note of this because it's a very important concept you must take note of. And of course, our result will be that. So our result will actually be positive 4.47 and negative 4.47 to 3 significant figures. Alex thinks, here's another example. Alex thinks that finding the square root of a number means that the answer is always smaller. What different types of numbers should she try to investigate this? Well, she could try integers, decimals, fractions, negative numbers, positive numbers, and after trying all this number, Alex would then be in a better position to test her conjecture. It's now time for you to pause the video and answer the other questions. Pause the video and answer questions 5 and 6 in 3 minutes. Here you're asked to use a calculator to help you solve y equal to 75. Assuming you've paused the video and you've answered the questions, here are the answers. To solve this, you know that you're going to take the square root because we know that solving equation means doing the inverse operation to make the variable stand on its own. So here, we're going to have to do the square root of y squared, which will get rid of the squaring of the y. So we now have y equal to the square root of 75. And of course, you remember that we learned that when you do this, you must acknowledge that for your equation, 2 answers will satisfy this equation: the positive answer and the negative answer. For this one, Annie thinks that negative 16 is a square number. So for question 6. Now, when So she says, when I put negative 4 squared into my calculator, it comes out as negative 16. What mistake has she made? Annie has made a mistake. So negative 16 is not the square of negative 4. Why? Negative 4 times negative 4 is equal to 16, not negative 16. What mistake has Annie made for B? Next, the so she shouldn't have gotten around to negative 4 because negative 4 squared should give us 16. Okay, so it's really important to know that negative 4 squared will give you negative 16. But if you put negative 4 in a bracket and then you square it, it's going to give you positive 16. So I hope that is really clear. All right. Pause the video and answer questions 7 and 8 in 3 minutes. Assuming you've paused the video and you've answered questions 7 and 8, here are the answers. So here, she says, if you square root a number, the answer is always smaller. Well, we can use an example to prove that she's incorrect because when we square root 1 over 4, we have a half. But a half is bigger than a quarter. So that's not right. That conjecture is not right. So that's why it's good to test conjectures before you reach conclusions. Question 8. Brett thinks of a number. He squares the number and subtracts 26. Brett's answer is 199. What was Brett's original number? Well, we can do this using algebra. So let's say the number that Brett thinks of is x. Okay? Brett thinks of a number. He squares the number. So Brett squares the number. So x squared. And subtracts 26. When he does that, his answer is 199. Now we're asked to find Brett's original number. You can see that we have formed an equation here and we can actually solve it. We can add 26 to both sides because remember, to solve the equation means we want to get the actual value for x squared. For x. So we need to get in the mission or process of getting rid or eliminating things that is preventing us from doing that. And remember, whatever we do to one side of the equation, we need to do it to the other side. So the 26 is now gone. 199 plus 26 will be 225. So see, 199 plus 26. 9 add 6 is 15. So we write 5, we carry 1. 9 add 2 is 11, plus the 1 we carried is 12. So we write 2, we carry 1. And that 1 is there. So 225. We now have x squared is equal to 225. Okay? Now, to get x, we need to do the square root of both sides. The square root on the left-hand side gets rid of the square root of that. Now, remember, we're solving an equation, so two numbers would be the answer. So it is either the square root of 225 is 15. So it could be 15 or negative 15. However, if you think about your problem, you can see that if you square negative 15, you're going to get positive 225. And then if you subtract 26, you're going to get that number. So remember, when solving equations, two solutions are possible. Is there more than one possible answer? Yes, he could have been thinking of negative 15, which is what we just discussed here. Pause the video and answer question 9 in 2 minutes. Assuming you've paused the video and you've answered question 9, here are the answers. Let's discuss them. So Dora is thinking of two numbers. She squares the numbers, then adds them. The answer is equal to another square number. What two numbers was Dora thinking of? Well, we could try to do this using algebra. We could have more than one answer for this. So if you think about it, let's say, for example, we try to use algebra because this is developing our math skill. So Dora is thinking of two numbers. So those numbers could be 3 and 4. It could be, 5 and, it could be 5 and 6. All right. So there can be more than one possible answer to do this. So I don't want this video to be too long. So I'm not going to, spend so much time trying to do it using algebra. And that brings us to the end of our lesson. So what we've learned so far is the roots of positive numbers. To do the roots of positive numbers, take note that the root of a positive number will always give us our result that we are interested in is always the positive result. We cannot say, for example, the root of positive 16 or the root of 16 is negative 4, even though we know that negative 4 squared will be equal to 16. But remember, the negative 4 that you're squaring must be in a bracket. However, note that when you're solving an equation which involves squaring, and then you have to do the inverse of squaring to find what the value of the variable is, your results can be either the positive or the negative result, depending on the context of the equation you're solving. Let's say, for example, you're solving an equation and we're talking about people. And then when you square the number, you get a negative and a positive, because when you're solving equations, you can take either the positive or the negative result. You're not going to take the negative result because in that case, you're only interested in the positive answer. The context determines the answer you choose. In some contexts, the answers that you choose satisfy both. Okay? So, and that brings us to the end of our lesson. So well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.